get really bad, the habitat might change forever. The old species will leave, searching for a better place to live. New species will come in. Life will keep going, but it won't look the same.
We're Lucas and Friends!
In every ecosystem, the plants and animals are connected. You can't mess with one species without affecting all the others. Food webs are delicate, like spider webs. We don't want to be all crazy pants and just go knocking them down. Now you have the whole picture. All living things need food for energy. If they can't make it, like plants do, they have to get it by eating other living things. On a small scale, you can think of this flow of energy as a food chain. But on the broader scale, it's more like a food web. No matter how you look at it, food is energy, and energy is life. If you enjoyed this, check out the rest of our channel and subscribe.
Select the shortest one.
Matter is space.
The world, the whole universe is made up of stuff, and we call this stuff matter. But what does all of this mean? What is matter? What's the difference between the matter that makes up wood and the matter that makes up water? And why does it matter? See what I did there? Let's see if we can answer these questions, and we'll start with the simplest ones. What is matter, and what are particles? You might have heard that everything is made of matter, and that's true. You, soccer balls, iPads, even your pet Fluffy, all made of matter. So that's interesting. But what is matter exactly? The scientific answer is matter is anything that has weight and takes up space. You already know about weight, right? That's just how heavy something is. Like if you've ever been to a doctor's office, the first thing they do is have you stand on the scale so they can measure how much you weigh. As for taking up space, another way of thinking about it is that all matter has volume. It simply fills the area it's in. When you pour water into a glass, for example, the water's volume is the amount of space that it takes up in the glass. So all matter has volume and weight. But it sure doesn't all look the same. Well, that's because matter comes in different forms, or states. Liquids are a state of matter that I'm sure you're familiar with. If you've ever poured yourself a drink while trying to watch TV, you might have noticed that liquids take up space. Because once the space inside your glass is full, right on the carpet. Sorry, Mom. You also know that water has weight if you carry a water bottle. As you drink from it, it gets lighter because you're removing water from it. Solids are matter too, of course, probably the most obvious kind. Rocks are solids, and so is ice, which is just solid water. Soccer balls are solid, iPads, your pet Fluffy, and every single guy in One Direction. And just like rocks, all those things have weight and take up space. Now, you know what's weird? Sometimes matter can't be seen or felt, but it's there. Like the air we breathe. Air is an example of gas, the third main state of matter. And I probably know what you're thinking. How do we know air, or any gas really, is there if we can't see it? Well, we can prove it by doing an experiment. Science.
Match the pictures.
Let's start by asking the question, is air matter? Because if it is, it should take up space and have weight, right? To see if air takes up space, look it. I can easily drop an empty balloon into this little box, but a full one won't fit. That's because the air that fills the space inside the balloon is bigger than the space inside the box. Now, does air have weight? Let's try something else. Take 2 empty balloons and tape them to the ends of a meter stick. Then we'll hang the meter stick on a string so that it's Now let's see what happens if we blow up just one of the balloons and put it back on our meter stick. Check it out. The end with the full balloon sinks. It weighs more than the empty balloon because the air gives it extra weight. The balloon full of air will always weigh more than the empty one because air is matter and matter has weight and takes up space, whether it's a liquid, a solid, or a gas. So listen, the next time someone tells you that something doesn't matter, you can tell them to their face that technically everything is matter. And tell them Sabrina said so. You ever hear someone say you look like $1,000,000? Well, you do. But you also look like 1,000,000 particles. Let me explain. You and I are both made of matter. I don't mean we matter like we're important, even though of course we are. I mean we actually are matter. Matter, as you know, is anything that has weight and takes up space. And we did a whole video about it, but what is matter made of?
Select the different
It's
one.
made of particles. So you, as a big thing of matter, are made of particles. The device you're watching this on is made of particles. Your dog is made of particles. You get the idea. Particles are so tiny though. You can't see them. Just picture them as super small balls packed together to form an object. And how an object looks and behaves, which we call its properties, has a lot to do with those tiny particles that it's made of. Let's take a look. You know that most matter comes in three states: solid, liquid, or gas. Particles in a solid are packed so tight that they don't move, and they keep you from moving through it, like a brick wall. Now, don't try running through a brick wall, just trust me on this. But in a liquid, there's more space between the particles. That extra room between them allows them to slide around. That's why you can stick an object into or through a liquid, like dropping a straw in a glass of soda or wading through a pool of water. And there is so much space between the constantly moving particles in a gas that you can move around in them easily. In fact, when you walk from one side of the room to the other, you walk through a bunch of gases that make up air. But if something is a solid, will it always stay a solid? Is a liquid always a liquid? Do gases ever become non-gases? To find out if matter can change states, let's find examples of when objects' properties change. Then we can figure out what's happening to their particles. Here's one, a candle. It's solid, right? Made of wax? But when you light the candle, the packed particles loosen up and the wax begins to melt. Liquid wax. So a solid can become a liquid. Now here's another. Let's say you've got a pot of water on the stove. If you heat a liquid up, its particles will move around so fast that they can't hold on to each other. When that happens, all of the particles fly apart and become a gas, like the steam you see when you boil water. So a liquid can become a gas. Okay, one more. How about a forest on a really cold night? Or even on your front lawn? When it's cold enough, water vapor, a gas in the air, turns into tiny crystals of frost, which you see on trees or grass. The free-floating particles in the gas join together and form a solid around the plants. So a gas can become a solid. But my favorite example of a state of change? The Wizard of Oz, definitely. Remember when the Wicked Witch of the West melts at the end? She totally goes from a solid to a liquid. Okay, but seriously, what does all of this mean? An object made of matter can change its properties when it changes states. And remember, it doesn't make a difference which state of matter an object is in, solid, liquid, or gas. It's still always matter. To sum up, matter is everywhere. Matter is made of particles. Therefore, particles are everywhere. So, like I always say, never trust a particle. They make up everything. So now that we have an idea of what matter is, we have to ask more questions. Like how to figure out what kind of matter something is made out of, and how we can figure out what an object is just by having measurements and making simple observations. Well, let's take a closer look.
Shapes. Marvelous. Match the shapes.
Hey guys, remember what it was like in preschool? If you don't remember, here's a reminder. It was way easier. Playing with colored blocks, learning shapes,
Let's have some
those
fun.
were the days. Good times. But here's a fun fact. When you were learning how to put all those yellow blocks in a line or stuffing square-shaped blocks to a square hole, you were also learning something very fundamental, and that is how to judge an object's properties. But what do we mean when we talk about the properties of stuff?
Match pattern.
Well, let's start with this. The stuff that makes up everything is called matter. Doesn't make any difference if it's a tiny grain of sand or all of the air that surrounds the earth. Everything is made of matter. And a property of matter is just any characteristic that we can list about it, like how it looks, feels, or acts. For example, my characteristics include having black hair, wearing glasses, having some wicked awesome nerd cred, and, well, you get the idea. Properties of matter are also things that we can observe. This means that they have differences that are big enough to notice. For instance, I'm currently observing that my desk is messier than it was 5 seconds ago. And to round it out, properties of matter are also able to be measured. That is, we can compare objects to each other. But instead of just looking at them and getting a general idea of how they compare, we measure them by using tools that give us values or numbers. Now, let's put all of these ideas to work by demonstrating how we can find a few basic properties of a simple object. Let me grab my measuring tape. Okay, look. I know I was just talking about how fun it was to play with blocks, but let me be clear. I am not playing with these blocks. This is science, people. Now, let's start with a couple of questions. 1. What properties does this block have? Well, there are some properties that we can observe, but we can't really measure or describe them with numbers, like this block's color, or what it's made of, or even the fact that it holds its shape, which makes it a solid. So, a better question to ask might be, what can we observe and measure about this block? Let's start with the big one here, length. Length is just the distance of something from end to end, and this block's length is 8.5 centimeters. Width, meanwhile, is the distance of something from side to side, and its width is 8.5 centimeters. Height. That's an easy one. It's the distance of an object from its bottom to its top. Not to mention a major factor in being able to play basketball successfully. And the height of this block is 9 centimeters. So length, width, and height are some of the most commonly used properties. But there are a lot of others too. For instance, our block is also an object shaped like a box that takes up space. That is, it fills up the space it's in. We call that space the block's volume. We can measure the volume of this block using math, based on the measurements that I just made. But we can also get a more general idea of its volume by making other observations. Like the medium block easily fits into the bigger block, so we know that the medium block has less volume than the bigger block. But there's no way the medium block is fitting into the little block, so we know that the medium block has more volume than this small block. Finally, weight is another measurable property of matter. Weight just tells us how heavy an object is. When you go to a doctor's office and they ask you to stand on a scale, they're using that scale to measure your weight. Got it? Good.